Problem 4 asks us what division expression is represented by this model. So the model, looking at the whole rectangle, we have a total of negative 1, 2, 3, 4, 5, 6, negative 12 inside the model. Negative 12, and you can see that that negative 12 is being divided equally among 4 groups. That's what division is. You share that negative 12 among 4 groups to find out what the quotient is. So negative 12 divided by 4 groups equals, each group has negative 3 in it, negative 3. And then by the rules that would give us the same answer. The signs are different, so the answer is negative, or looking at baby Mindy, we could use that also. 2 minus signs for the eyes and a plus sign for the mouth, and then we have a negative times a positive, and we're left with a negative, so our quotient should be negative. So negative 12 divided by 4 is negative 3, and the model shows that as well. The one that matches would be not this one. Negative 12 divided by 4. There we go, right there. Problem number 5. The array below represents the result of multiplication of 2 integers. Write 2 different number sentences that give this result. So we have, let's see, 2 columns times 1, 2, 3 rows. So 2 times 3 equals 1, 2, 3, 4, 5, 6 positives. 2 times 3 equals 6. That's the easy one to come up with. The harder one is remembering that we can also get a positive product, positive 6, by multiplying 2 negative integers. Negative 2 times negative 3. And what that really means is negative 2 times negative 3 is like the opposite of 2 times negative 3. So 2 times negative 3 would look like this. We'd have 2 columns of 3 negatives. 2 columns of 3 negatives. And then taking this negative into account, we want the opposite of that, and that would make them all positive, and we get the same model as you see here. So these are the 2 number sentences we're looking for here. Now, you will get a question like this on the test if you put 2 times 3 equals 6 and 3 times 2 equals 6. Those are not 2 different number sentences, so you only get partial credit for that. Number 6, Luis is building a square floor for a treehouse. Anytime you're doing a word problem and they refer to a square floor, a rectangular garden, a triangular pizza slice, anything like that, draw the shape. So square floor. The area of the floor is 81 feet squared. Remember, we're showing area on the inside like this. What are the dimensions of the floor? Well, we know all the sides are the same length, but we don't know what they are. So if we know the area of a square and we want to find the side length, the function we learned for that is square root. Square root of 81 equals, and then you have to think what the answer here will be. What number times itself gives you 81? So if you weren't sure, you might try 7 times 7, 49, that's too small. 8 times 8, 64. 9 times 9, 81. There it is. So square root of 81 equals 9, so S equals 9. So the dimensions of the floor would be 9 by 9 feet. I should put my units. By, let me do it right. 9 feet by 9 feet. Okay, let me see if I can get 7 in before this video ends. Definitely. Okay, number 7. Write 2 number sentences to represent the area and side length of the following square. We have 1, 2, 3 columns, and we have 1, 2, 3 rows. So the area of this square would be 3 times 3 or 9. So 3 times 3 equals 9, or 3 squared equals 9. These are the same number sentence. This is one of the number sentences we're looking for. The other number sentence would be just like the last problem we did, taking the area and the square root of the area equals the side length of the square, which is 3. So here's one number sentence, here's the other number sentence. Okay, I'll pick up the review with problem 8 on the next video.